Well, thank you very much, Susan. Nice job, as a matter of fact. You know, today's webinar, addressing boiler tuning, is again being covered at the request of our ever-growing audience, who just wanted to have a better grasp on the what and the why and the how of burner adjustment to really to maximize energy conservation, also reliability of the equipment, and then, of course, safety is paramount. So today, we're going to be spending, as Susan mentioned, the next 40 or 45 minutes to discuss the art of boiler tuning, and that's going to include, you know, what tuning really is. We'll then get into why it's important. Also, you know, why is tuning considered an art? Are we further elaborating here? Are we kind of extending ourselves and being a bit presumptuous? Not really. Based on our experience, tuning is really an art. We'll then get into the pre-tune-up procedures that one has to go through beforehand. This is often overlooked when a service technician comes in, or the expert within the plant itself. They sometimes don't spend enough time looking at what goes into the tune-up procedures beforehand. Then the proper procedures during the tune-up, what we would recommend there, and then finally we'll cap off with the post-tune-up procedures. So burner tuning, when we look at the definition, is essentially the adjustment of the burner's fuel-air ratio control so that we remain safe without overly wasting fuel by going too fuel-rich on one side or too lean on the other as the burner modulates between low and high fire. Now, and though this might seem rather intuitive, you would really be surprised at the number of boilers out there running at the extremes, and they're not only wasting thousands of dollars annually in fuel cost, but they're also incurring significant downtime costs, to say nothing about the safety issues that have been compromised. Now, many operating personnel we've found, they just don't understand. And that's the majority of cases. And there are some, the minority, that just don't care. So when we talk of burner tuning today, we're going to be talking about commercial and industrial boilers, both steam and hot water, because the burner, when you think about it, doesn't really care if it's heating hot water for comfort heating or if it's heating hot water to produce steam. So let's get into it. You know, why is tuning important? Well, to start with, and as many of you have already seen and heard in other webinars, the fuel spend is the major dollar outlay in a plant's overall operating budget. And of course, the boiler plays a key role in this expense, as it will consume, on average, 4 times its initial cost in fuel every year. Now, here's a boiler that had a burner way out of tune, very rich firing. And it was allowed to persist because the operator just didn't understand what was going on. Now, it was firing rich, as I said, and in the soot buildup, it built up to the point that the tubes overheated and broke from their welds to the tube sheet. Now, this not only caused excessive dollars to be blown out the stack and energy losses, but downtime, too, as the boiler needed to be extensively repaired. And by the way, I might add, this was a natural gas-fired boiler. Remember, combustion involves a chemical reaction we refer to as oxidation, and it includes a number of elements. First, as you can see in the slide on the left side, we need fuel, which is carbon-based and contains other elements such as hydrogen, and in some oil-based fuels we also have nitrogen, along with varying amounts of sulfur. And then we have the air, which contains oxygen, about 21%, and then nitrogen. Now, mixing these all together and having ignition, we have oxidation, and then the resultant combustion. Now, the output from the chemical reaction is heat, and this is on the right side of the slide here. We have heat, carbon dioxide, and, of course, water, and hopefully not excessive amounts of CO. But you will have nitrogen oxides, And when burning oil, you may also have sulfur oxides too, both of which in parts of the country are considerably restricted. So tuning is going to impact all of this while having a major impact on the overall efficiency of the boiler. For instance, here you see a curve showing the relationship of excess air to efficiency when burning natural gas. Now, note the horizontal axis on the bottom showing the excess air amount and expressed either as a % of excess air or O2. In other words, where you see the first arrow here, 15% excess air is the same as 3% O2. They're interchangeable. Now, looking at the burner boiler manufacturers today and looking at our recommendations in total, we would like to keep the burner running as close to 3% O2 or 15% excess air as much as we possibly can. In other words, if the boiler runs most of the time at, let's say, 80% of its capacity, then what we try to do is hold 3% at this point. Now, as you can also see, if that burner gets out of tune and it drifts to the lean side of the curve, or in this case to the right, and reaches 7% O2, we've lost 2% efficiency. In other words, for every 2% increase in O2, for every 2% increase in O2, we lose 1%. And keep in mind that many process boiler applications out there today have gas bills that exceed $1 million a year. So when we're talking 1%, that's $10,000. It's not chump change. And believe me, it happens so often. Now, here's the other thing to keep in mind with regard to why it's important to tune a burner. There are a number of variables which impact its fuel-air ratio and occur naturally and beyond our control. Now, an O2 trim system will help in this regard, keeping the ratio consistent when certain variations occur. But large ambient air swings often are beyond its control band. And so in these cases, it's a very good idea to tune the boiler in both the spring and fall to assure the burner doesn't swing to the right or to the left of the acceptable curve, thereby causing excessive sooting or high excess air, and in that particular case, just blowing valuable heat out the stack. Now, another side benefit I wanted to mention of tuning the burner are the new EPA boiler rules covering the major and area source boilers, stipulating that if you fall into one of these categories, and you can see our website for details, periodic tune-ups will be required. The major exception to this are those boilers which fall into the area source category and are burning gas or have an O2 trim system. They don't need to periodically tune unless they burn fuel oil and the burning of it exceeds 48 hours annually and it's not the result of a gas curtailment. So, area source gas-fired boiler owners should not be lulled into thinking they're exempt, because they may not be. Again, I would suggest that you see our website for all the details about the new major and area source boiler rules. It's all very nicely explained, and there's quite a bit to it. So, with all of this as a bit of general commentary about tuning, let's start getting into the meat of the subject today, the actual burner tuning. First of all, it starts with a good, preferably factory-trained service technician who really understands combustion and how the boiler extracts its heat from the combustion process. Now, this means that they understand and appreciate how heat transfer works and why it's so important to have a properly matched burner and furnace working together. Now, additionally, technicians need to be versed on the electromechanical advances today and how best to troubleshoot and adjust this type of equipment. They also need to have hands-on field experience, and this, believe me, is a process, and for many it takes several years to get to full proficiency. Now, these technicians, they also have to be fully equipped. They have to have, besides the tools that are required, including the gas analyzer that you see here, they have to have immediate parts availability. So we like to see trucks that pull up or vans that pull up that are fully part stocked. And then they have to have readily accessible technical backup if the situation gets beyond them. And by that I mean a call on their cell phone to a person back at the office or whatever it might be, telling them about the problem they've incurred, and then those experts can help them get through it to minimize the time on the job and help our customer from that perspective. Now, be mindful too, the technician must be versed on various types of burners, including the integral as well as the gun type. Now, each boiler burner package, it's going to have its own unique signature. And you know, the technician needs to be able to see this and then make the proper adjustments accordingly. And that's why time and grade is so important here. And that's why this hands-on experience and skill, which is why we often refer to this as tuning being an art, because the person who's doing it has got the hands-on tactical experience and got the skill that it takes to be able to do this properly. Because the last thing that we want to have happen is a fireside occurrence. And in this particular case, we're getting on the wrong side of the curve. We've gone rich and we've had an uncontrolled ignition. We don't want that. Let me show you exactly what I mean by this. In the slide, the arrow, red arrow, is pointing to what is referred to as stoichiometric combustion, whereby we are combusting the fuel with zero excess air and no CO. In other words, it's 100% combustion efficiency. Now, as we drift to the left of the curve, you see how the CO increases. Now, that's unburned fuel. And if we go to the right, the increase in O2 or excess air. Now, from a safety perspective, it's best to stay to the right of the curve to avoid uncontrolled combustion and unwanted occurrences. However, too much excess air wastes fuel, as I showed you previously. So staying at 3% O2 or 15% excess air as much as possible is what the industry has found to be a good compromise. And this is what a good boiler technician knows, what a good boiler technician appreciates and will strive to accomplish. Now, once the technician arrives to tune the boiler, he or she will normally start with an initial boiler room review involving a number of steps, as you can see on the slide here. So what I'd like to do is to take a close look at each one of these. Beginning with notating the information on the boiler nameplate, including the boiler model, its design pressure, and the maximum input to the burner. That's how we start. For instance, if it's natural gas firing, the nameplate in this example reads 36,821,000 BTU per hour input to the burner. Now, if we figure 1,000 BTU per cubic foot of gas, that's about 36,821 cubic feet per hour that the burner is delivering for combustion. Now, how the burner is then set up from a capacity perspective and how best the fuel and air ratio is controlled will determine how effectively and efficiently this boiler will operate. The next thing the technician will check is to see what the burner management system or programmer is that he's dealing with. Now, this control, and I'm looking at this control right here, a fire eye, the red box that you see here, this control is the gateway for burner control and will not allow the burner sequence to advance if certain safeties are not powered. For instance, the pre-ignition interlock, such as the proof of closure switch. If it is not closed on the main gas valve, pilot light off will not occur. And the same with the running interlock, such as the combustion air proving switch and the low water controls. If the respective switches break, the burner will shut down. The unit will go through a post-purge before shutting off completely. In other words, there is a given sequence in various terminals which need to be energized within the programmer for the burner to start, for it then to advance, and then continue to fire. And the technician needs to know the burner management system's respective characteristics, regardless if it's an electromechanical device or a PLC-based control, working off a PLC-based control platform. Now next we need to check the fuel-air ratio control system. This is very important. Do we have a single point positioning system with a single drive motor and a single jack shaft, which is powering these linkages and cams? Or do I have a parallel positioning system with independent actuators controlling fuel and air and doing this through a central controller? In other words, how do I adjust the ratios on this burner? Now, if it's a linkage system, single point positioning, I'll need wrenches, including the Allen head wrench that I showed you before. Now, if it's actuator driven, well then much of the tuning is digital through the central controller or through the PLC-based interface. Now, having accomplished that, from here, we're going to go to the end of the gas train, and we're going to check the gas pressure coming into the regulator. We have to assure that we are within the range the manufacturer has recommended to achieve full input to the burner. Now, if it's too low, it may involve calling the local gas utility for more pressure, or I should say, and/or determining what else is on that service within the plant which may be robbing gas from the boiler. Next, we want to check to see if the boiler system is filled to the proper level with water. Now, in a steam boiler, it's looking at the gauge glass connected to the low water cutoff, and in a hot water boiler, we can check the expansion tank to see if it's filled and charged properly. Many times these compression tanks that you see here on the slide will have like a bell and gasket air troll tank fitting, where you can open up that little valve and see if water spurts out. In that particular case, you know that the system is flooded and we have proper air within the expansion tank itself. Now, we also want to check the breeching and stack arrangement, looking for any signs of leakage, carbon on certain joints on that breeching, any carbon buildup, or possible condensation indicating the boiler has been operating at a very low exit gas temperature, causing the flue gases to reach the dew point. Now, you're also looking for excessive restrictions or bends which are going to increase the pressure drop in the system, imposing a back pressure as a result on the burner. And if that's done, it's going to be, if you have that, it's going to be extremely difficult to tune, or maybe even impossible. Now, all manufacturers have draft tolerances on their equipment, so exceeding these limits will give the technician some real problems, to say nothing about the compromises to efficiency and safety if we haven't got proper draft. Now, combustion air is the next important thing to look for, as we need to assure that we have plenty of combustion and ventilation air in the boiler room. Now, a good rule of thumb is, as you see here, we need 1 square inch per 2,000 BTU input if it's an open area, or 1 square inch per 4,000 BTU input if a forced air fan is employed, as you see in the picture. Now, not having enough combustion ventilation air will also make tuning difficult to impossible. And it can be a real safety issue as well, because of improper combustion generating very, very high levels of CO. So it's really nothing to fool with and often overlooked. Now, assuring ourselves that we are fine with combustion and ventilation air, we now move to the sources of feed water for the boiler. Now, do we have a vented receiver, or do we have a deaerator? Are they operational with proper levels and temperatures? And if it's a deaerator, does it have the proper pressure? In other words, let's say it's operating at 5 pounds. If we've got 5 pounds of pressure, the temperature in that tank should be about 230 degrees, or specifically 227 degrees. And so if these are not there, the adjustments have to be made, because it's going to impact how you tune that boiler, how effectively you tune it. You wouldn't think so, but it does have an impact. The feed water temperature has an impact. Now, along these same lines, You should also check to see if an automatic feed water valve is part of the system. Now, if it's on-off, check for that, or is it modulating? Now, if it is on-off, and depending upon the temperature of the incoming boiler feed water, it could cause nuisance shutdowns with the boiler going out on low water because of large slugs of relatively cold water causing the steam bubbles within the drum or the shell to collapse, dropping the water line and shutting the burner off. That's why it's so important to check these things before you start. Electrical safety, always a key consideration when working on boilers. So we want to assure ourselves not only that we have proper electrical supply to power the unit and its accessory equipment, but also that there is no lockout tag-out procedures taking place while we are trying to do our job. And then we highly recommend that you check the boiler room log to see if there's anything there that may indicate any problems, especially those of a habitual nature, which would impact the proper tuning of the burner. For instance, gas pressure, does it fluctuate? Ambient air temperature, huge. Or the flue gas temperature deviations. These will all impact efficiency and proper tuning. And finally, we want to make sure you understand what the customer is expecting. What are the expectations regarding excess air? What, of course, they're going to want as efficient as possible, I'm sure, but they want to be safe, obviously. So you may want to explain to them that you're going to try to get as close to 3% O2 or 15% excess air as you can throughout the turn-down range. Also, that we're going to try to eliminate or mitigate CO formation. And then what is their NOx expectations? A uncontrolled natural gas-fired burner is going to generate about 120 parts per million of NOx. Well, this burner may have been set up for NOx control, or it may be a low NOx burner, and they want to have 30, or they may want to have 60 parts per million, whatever it may be. You've got to know that, and then make adjustments accordingly. So these then become the benchmarks that we need to hit to satisfy him or her, and will spell the difference between a poor, a mediocre, or a first-class tune-up. So, getting started with the actual tuning of the burner, we are going to assume in this particular discussion today that we have a natural gas-fired boiler. It has a load. The boiler is hot, so it's up to temperature or near pressure, and we are, as I say, near but not at the operating pressure, or the boiler operating pressure or temperature can be raised to allow the window that we need to adjust within. So the boiler's not cycling off all the time when you're trying to drive to high fire and set the fuel-air ratio. So we start by inserting the analyzer probe into the stack for the various readings that we will be monitoring, such as the stack temperature, the O2, and the CO, as you see here. Now, following the insertion of the probe in the stack, which may involve drilling a small hole to accommodate it, we ask you to power the burner switch and place the burner in the manual mode. And at the low fire point, by manipulating the potentiometer that you see right here, we'll take that down to the low fire point. Now, at this point, the burner is under the control of the burner management system, or the programmer as we call it, and it's going to go through its sequence beginning with pre-purge, where the damper, first of all, the blower motor will start, the fan starts, and then it will, the damper will travel from low to a position of high fire, and it's going to be in a single point positioning system. It's going to be closing switches along the way. So the programmer knows exactly where it is. And once it gets to high fire, it's going to hold for about 30 seconds. And what we're trying to do here is make sure that we've got ample air flushing through that furnace and through in a fire tube boiler, through the tube passes, so that we can purge it of any combustible mix. And then once that's been attained, we then return to low fire before we get into trial for pilot ignition. Now, if during the pilot light-off, you notice the pilot is too small, or it's lazy, it seems unstable, or is burning too rich, and the voltage or the microamp signal shown on your meter or the programmer is below the recommendation, then turn the burner switch off and let the burner go through a post-purge, and then it will shut off. After that, turn the burner switch back on. And when the programmer indicates trial for pilot ignition, turn the pilot test switch at the top of the programmer on. This will allow you to make the adjustments to the pilot with the programmer not advancing beyond the pilot ignition point. And then the adjustments are made through the gas pilot regulator, and maybe the manual cock in the pilot line itself may be moved a bit. So once the pilot is adjusted, then put the pilot test switch back to the run position and then observe main flame ignition. Now, as you see in the picture here, we're now in low fire, and we need to observe the flame for any signs of sooting or overall instability. And next, we check the O2 analyzer for the O2 and CO readings. Now, this needs to be in a range as specified by the manufacturer, but in many cases, if the CO is above 50 to 100 parts per million, the burner is running too rich, and either the fuel needs to be cut back or the air increased. Now, a good excess air at low fire is normally between 5 and 8% O2. And this is just kind of a general rule. Now, there are burners out there, and there are burner boiler manufacturers out there that have packages that will operate at 15% or 3% O2 at low fire. But on average, 5 to 8% is a pretty good target at low fire. You also want to check the manifold pressure at the burner entrance to make sure we are within the operating parameters as detailed by the manufacturer to assure proper input at low fire. And when I'm talking about the adjustments to the fuel or air, and when considering tuning a pre-commissioned boiler burner, we're probably only talking about relatively small cam adjustments on a single point positioning system that uses a motor driving a single jack shaft and associated linkages and cams. And you can see it as depicted on the slide here. So just small cam adjustments to that cam on the left should be sufficient. Now, once low fire is set, we now manually increase the firing rate incrementally while observing the flame and looking for signs of sooting and instability. This is where that experience comes in, why burner tuning, boiler tuning is an art, because this person has an eye for this. So we're looking for that, any instability. Now, at the same time, we're also watching our analyzer at each control point and making cam adjustments and possibly linkage adjustments to bring the fuel-air ratio as close to the customer's wishes as possible while maintaining safe firing conditions at all times. This becomes paramount. Again, if you can hold 3% O2 or 15% excess air from medium to high fire with, say, no more than 50 parts per million CO, the adjustment tuning is excellent. Also inquire of the operating staff as to where the boiler fires most of the time. As I mentioned before, is it high fire? Is it 75% or is it 50%? Wherever that point is, you want to assure that you have the combustion set to the maximum efficiency at that particular rate while maintaining a safe margin of excess air. As I said, 3% O2 or 15% excess air. Now, this while holding as close to 15% throughout the firing range. We don't want to have humps in the cam. We want as close to a linear curve as possible as we drive from low to high fire. So it's a compromise between maximum efficiency and always maintaining safety. It's a trade-off. Now, arriving at high fire and making the adjustments along the way to the linkages or the actuators, you need to again check the manifold pressure to assure you have full input as defined by the manufacturer and expressed in either inches of water column or PSI. Now from here, manually bring the burner back to low fire. check the combustion readings as you descend, making any minor tweaks as necessary. And then during this time, you're also watching the linkage movement on a single point positioning system to assure you have no hitches, hysteresis, or slippage. Then confirming this, switch the control from manual to automatic, allowing the burner to modulate on its own under full control of the burner management system. Now, it is at this point, and while the burner has reached its stability point with regard to load matching, you need to watch the boiler pressure or temperature in relationship to the stack temperature. Now, a well-tuned boiler burner package will register a stack temperature between 50 and 100 degrees above the saturation or water temperature in the boiler. Anything above this will indicate a dirty boiler or one which has flue gas bypass issues. In other words, compromised baffles between the gas passes, or it's badly scaled up. And for every 40-degree rise above the benchmark, you've lost 1%. Very important. Now, additionally, at the end of the tuning, we would suggest you check these safeties, starting with the low water cutoff. Now, beginning with an OK from the operating staff, the best check of this safety, the low water cutoff, is an evaporation test where you secure or shut off the feed water supply and then let the boiler evaporate off naturally to the low water shutoff or cutoff point. Seeing a proper shutoff, then reopen the feed valve and allow the boiler to normally cycle through an automatic relight. Now, you'll also want to check the auxiliary low water cutoff in the same way, but in this case you have to jump around the low water cutoff to allow the fault to occur. And please make sure the jumper is removed after checking the auxiliary low water cutoff, because you don't want to bypass that control. You certainly, we certainly don't want to see what we call fireside occurrences, but boy, a waterside occurrence can be even worse. These controls, the primary low water cutoff and the auxiliary, are your major defenses against that occurrence of waterside occurring. We also suggest that you test the flame scanner. Pull it from its location to allow a trip within 2 to 4 seconds, confirming that it's properly operating under an extreme condition. And then move to the combustion air proving switch and the high and low gas pressure switches. And these are tested by changing the settings, either changing them up or down to trigger the trip. Please make sure that you note the operating settings to be returned to before conducting the test, so that you can get them back to those positions after you've determined whether or not these are working effectively. Just kind of common sense. You know, in summary, burner tuning is indeed an art, as I mentioned. And to do it properly, it requires factory training and experience to maximize efficiency and safety. Now, there might be people within the plant that the customer has that are very adept at this. I'm not saying that they aren't. But boy, if they are not, and they haven't done it enough, it really pays to have an expert come in to do it properly. There are also many benefits to tuning, including saving energy while increasing reliability and safety. We've also found that tuning the burner twice per year during the spring and fall is normally a good idea because of the dramatic air temperature density changes during these particular times that can affect certainly the excess air, one way or the other. Reviewing the boiler room information and accessory equipment before starting the tuning is a very good idea, we found. Oftentimes conditions are found which need to be corrected beforehand to allow for proper tuning. This can save time, make it a much more effective and much more productive tune for the customer. Of course, having the proper tools, including a reliable flue gas analyzer, is essential, along with a ready supply of parts and expert assistance, as I mentioned, that is a good fallback should the technician not have an answer for a particular problem he or she may run into. And remember, the boiler needs to be hot before it's tuned. I can't emphasize this enough. That boiler's got to be up to temperature before it's tuned, because a cold boiler will throw off the actual operating O2s and CO readings dramatically. And then proper fuel pressures and adequate combustion air are essential for achieving full input and maximum efficiency and safety, while also understanding that what you're trying to achieve is the optimum match between overall efficiency without compromising safety. So it's a trade-off there. Now, there's also a correlation between stack temperature and efficiency, and it's between 50 and 100 degrees above the operating temperature. Now, if you have a boiler that's operating, let's say, at 100 pounds, that's 338 degrees. So a well-tuned boiler at high fire will be about 440 degrees. Now, obviously, when it modulates down in firing rate, that temperature will decline. And also remember that once you have that benchmark at certain firing rates, and you deviate by 40 degrees or more, you've lost 1% right there. And it tells you either that boiler is sooting up, it's got a compromised baffles, or it's got scale on the water side. And finally, once the burner is tuned, checking the safety is a very good idea, especially the low water cutoffs. Can't not emphasize that enough. So, that's the summary. Those are the takeaways that I would like to leave you with today about tune-ups. So let's open it up for questions.
Thank you, Steve, for the great presentation. At this time, I'd like to introduce Ron Churchill. He is our Senior Application Engineer here at Cleaver-Brooks, and he has been with the company for over 23 years, worked in industrial water tube boiler field service. He's worked in our service department, our research and development department, and our conversions department, and now the technical specialist in our aftermarket department. So we're happy to have him with us, and he was with us on our last webinar, and he did such a great job we had invited him back. So again, thanks, Ron, for joining us for our expert panel. While we wait for, well, we already have a good many of questions coming in, and it's good, Steve, that we kind of zipped right through this one and we have a little bit more time for questions because I think we're going to need it. I'd like to clarify something that was brought to my attention a little bit earlier. In the opening, I stated that we did 9 to 10 webinars per month. It is not per month, it's per year. I think Steve would shoot me and put me out to pasture if we attempted to do 9 to 10 a month. So I apologize for that. We do 9 to 10 a year, and you can find those archived on our Cleaver-Brooks website at cleaver-brooks.com/webinars. Would I like to also reiterate that we offer the certificates of completion that you can use to gain your professional development hours. Usually our programs equate to 1 PDH, and that is at the discretion of your local agency. If you need anything further than the certificate, you may get the slides from our website and or download a summary and outline as well. All right, we will open it up for questions now, and let me go back to this one, Steve. Let's talk about O2 trim, why it's important, how does it play into tuning the burner?
Well, first of all, O2 trim can be very important. When you've got these variations that occur, in the environment, such as relative humidity, barometric pressure, ambient air temperature, and things like that, once the boiler is properly tuned, that O2 trim system will make up for some of those deviations and keep us at that, let's say, 3% O2 or 15% excess air. However, what I want to make sure everybody understands is an O2 trim system in and of itself will not tune a burner. It's got to be properly tuned first, and then it will make these minor adjustments as certain things within the environment change.
I can add something.
Okay, Ron wants to add to that?
Like Steve said, it doesn't tune the boiler. When the technician starting the boiler up sets it up, he'll program into the controller what the expected O2 trim, or the O2 level is supposed to be at different points along a line that's input into the PLC or some kind of a controller. And there's a feedback from the stack sensor that tells it where it actually is, and then it'll either, if it's an air trim system, adjust the air damper to let more or less air in to get it to the percent that they want, or if it's a fuel trim, it'll adjust the pressure on the gas regulator and bring the O2 where it's supposed to be. So that's how it's set up. We can take the next question, Susan.
All right, thank you, Ron. All right, let's take this one. If the ambient temperature is affecting the tuning performance, why did you recommend tuning in spring or fall? Why not at the extremes like summer or winter?
Well, what we mean is that's after the major changes in temperature and ambient pressure, after the seasons. Otherwise, an O2 trim system could take care of it throughout the whole year. I think the reason we say that is, like I said, that's after the major changes in temperature and pressure in the weather. You know, certainly if there's a major change in temperature, you could have someone come in and retune the boiler if you're concerned about efficiency, and ultimately, if you got a bigger system and it's worthwhile, a payback, an O2 trim system could be put into place.
Well, what we're saying, obviously, is in the spring of the year, the weather changes, the temperature rises, that air becomes less dense. And so you're making adjustments at that particular point. But also, as part of that boiler room log, you should be logging ambient temperatures in the room. And if during the course of from spring until, let's say, fall, you start to get some major corrections, an O2 trim may be able to handle that if you have one, but if you get beyond its control band, it won't be able to compensate enough. And because I've been in boiler rooms that might have been tuned in spring and they tuned it was 80 degrees, but I've been in the summer and it's gone up to over 100. So sometimes the O2 trim system may not be able to compensate for that. Remember, as that temperature increases, the pounds of air decreases, okay? It's an inverse relationship. And that's why it's so important in the fall of the year. We're not saying this is mandatory. We're just saying it might be a good idea if you've got these variations, because in the fall, now the temperature starts going down, the density of the air increases, again, inverse relationship, and we want to make sure we're not going too far on the right side of the curve, too much excess air blowing BTUs out the stack. So it's kind of a balancing act, but again, we have to look at that boiler room log, and that should be every single day. That ambient temperature should be documented. Because if it starts to increase or fall, it's going to definitely affect the fuel-air relationship. And if you've got an O2 trim system, it could mitigate it to a large extent, but maybe not all the way.
All right, thanks, Steve. Next question. Can the boiler be tuned correctly if its stack combines with a common boiler plant stack and greater than one boiler is simultaneously firing, including the one being tuned?
Yes. In our last presentation, Steve went over, and I think in this one he touched on the stack arrangement. One of the things you're going to have to look at when you get into a boiler room would be the arrangement of the stack and how it's sized and engineered. If it's done correctly, you may be able to run more than one boiler into a common stack without modulating control dampers and things like that. A lot of times when you get into multiple boilers in a stack, you're going to have to use a modulating damper to control the draft at each boiler's exit, because that's where it's important. And there are certain types of boilers, some of the newer canister style burners, I guess, where they're more touchy to small changes in stack pressure, and some manufacturers don't recommend more than one boiler in a stack for some kind of boiler, so that's got to be taken into context with what you're working on.
You know, I might add to that, Ron, if I might, and that's an excellent question, because, and that's why you've got a pre-commissioned boiler here. You're coming in to tune it up, and maybe they've added a boiler, and or maybe the last time the other boiler wasn't firing, and they're commonly breached and going into the same vertical stack. Every boiler burner manufacturer is going to tell you what they want at the vent outlet. Either I want 0 pressure or no more than, let's say, a swing of a ½ an inch, plus or minus. And so with that other boiler firing, and the other thing that I should have mentioned that you need is a manometer to tell you what the pressure is at the vent outlet. And if it is more or less than what the manufacturer is requiring, then maybe a stack damper, as Ron just mentioned, is the only solution to the problem. Draft is extremely critical on these boilers to be able to tune those burners properly and get the fuel-air ratio that you need. So understand what the minimum, maximum is required by the manufacturer at the vent stub. Having a manometer with you is extremely important too, and then make sure that you've got the extreme condition, that both boilers or all three boilers, however many you have connected to that stack, are all firing. So you've got the extreme condition now, and see what your drafts are at that particular point.
Okay, all right, move into the next question. Is checking for a blue flame a good indicator of complete combustion, or the flue analyzer, is it a better indicator?
Okay, we call that the Ringelmann eye. It's kind of a joke. Over the years, in older boilers, you can kind of say, well, I look at the flame. A lot of people would think that if it's a blue flame, it's okay, but you can't truly tell what the combustion's doing just by looking at the flame. You could look at a flame to tell if you needed to tune up if it was impinging, or if one half of the fire didn't have a flame there, you know, when you're looking at from the rear of the boiler in. But to get a true idea of what's going on, you're going to need to have, like Steve, a stacked draft, your O2s, your CO, your nitrous oxides, whatever you're trying to pinpoint, and you're going to have to work with either the cams or the parallel positioning system to get things back to the point on the right side of the stoichiometric where your burner is supposed to be set up.
If I might add to that, Ron, you know, yep. You look at a blue flame, and normally speaking, a blue flame is going to indicate that things are set up fairly well, but it's not going to tell you where your excess air level is, and you might even be generating CO. As I mentioned before, each burner has a signature, and that's why the analyzer is so important. You can look through that sight port and take a look at a blue flame. There's no impingement. There's no yellow tailings. It looks really good. And you stick an analyzer in the stack and you find out your excess air is, you know, over the moon. And you might also be generating CO beyond 50 to 100 parts per million. It's really deceiving. So a flue gas analyzer is paramount. Don't just look at the flame. After you've set it up, and after you've seen, you know, where your O2s and CO is and so on, where your NOx level is in that case, then look at the signature at that point too, and say, okay, this is what it looks like when it's really well tuned. So they kind of go hand in hand, but don't just rely on one. Always rely on the flue gas analyzer.
All right, and then next question. How can you manage the high fire pressure at the manifold versus the low fire setting? For example, setting up high fire rate and then being too rich in low fire.
That's a good question. When you're setting up, that's more along the lines if you're setting a new boiler up during commissioning, and you know an experienced service tech should be doing this anyway. But what he's saying is you're going to, before you waste a lot of time setting your combustion all along the curve, and maybe thinking you might have to make linkage or other kinds of adjustments that'll take more time, technician's going to try to get it up to high fire safely. And when he gets there, you take your gas meter reading and pressures and calculate your gas flow or oil flow. And once you bring it back down to low fire, there may be a little bit of a change because you may have had to adjust the regulator or something, and it's going to affect your low fire setting. So that's where the setting of the cam tweaking that Steve was talking about will come into play at the low fire end. And if you can't go far enough there, then you may have some kind of a problem of where the linkages are set up in the arms and the links of the linkage between the arm on a jack shaft and the gas valve stem or the oil stem. And unless you're experienced with that boiler burner combination and trained on how to do this, you really shouldn't be fooling around with the linkages because it can get way out of whack and get yourself in a mess that you may not be able to get out of. Typically when a boiler is released to the market. It's gone through UL testing or some other kind of testing, and UL representative would have been to the factory's test place and witnessed what's gone on and documented how all the linkages and arms are set on the whole system, and it's documented, and that's how the boilers generally get set up and sent out of the factory. So like Steve said, typically it's going to be fine tuning of cams should take care of most problems on a boiler that's been properly set up from the factory and tested.
Okay. When testing digester gas, what gas source should you set the combustion analyzer to?
Could you repeat that again, Susan?
I sure can.
Yeah.
When testing digester gas, what gas source should you set the combustion analyzer to?
What gas what?
Source.
How
you should set the analyzer when you're firing digester gas. I would assume, well, digester gas and natural.
Methane.
That's got lower calorific value.
Correct. Methane gas is a lot different than natural gas in few respects. Setting it up, typically the O2s may not be very much different when you're done, setting up the curve. The differences are going to be the turn down on the burner, and making sure the gas train is a proper gas train to remove any liquids or anything like that. But I really don't think the O2 levels may be too much different between O2 and gas, just as they are with oil and gas. It's setting it up safely and having a
So what would you recommend?
Safe combustion.
Would you recommend setting up? Let's say that the technician is there to set up both digester as well as natural.
Okay.
Okay, so the primary fuel, let's say, is going to be digester.
Okay.
And then we'll trigger back to natural gas based on pressure, availability of the methane or the digester gas. So we got an automatic changeover. So how does he set that up?
You'd have to set it up manually, one fuel first and the other fuel manual.
Okay.
And set both your curves, and then depending on whether you have single point positioning or parallel point positioning, set them up according to that. And then the auto fuel changeover, like you said, when there's not enough digester, if the pressure's dropping in the digester system, it's not producing enough, there's a pressure switch that will trip a system that will safely go from methane fuel firing to gas fuel firing, and it's going to automatically run wherever you set your curve.
In most cases, we're going to have dual gas trains. We're going to have one for natural, one for the digester.
Yes.
We're going to have the stainless steel components.
Right.
And so you can have the butterfly valves differently. There'll be different cams.
You'll have different size holes in the gas can. You'll have different size gas trains, lower pressure gas, usually on the methane, so a lot larger gas train. You'll have different kinds of valves. You'll have a more...
Like a Maxon type.
Maxon is one, and the Zurich, there's several.
Yeah. And
a lot of them don't even, they won't use an air compressor to run the valves instead of electricity. So it's a little bit different.
Yeah. Hopefully we answered it.
All right, next question. Let's see. How can you test the HPGS if the lowest setting on the HPGS is higher than your actual gas pressure?
What?
I see this question here. How can I?
You mean the high gas pressure switch?
Yeah.
Well, you want to lower the setting to see if it trips.
There's a procedure to test those that probably only a trained service technician should do, and you could do what Steve said and manually trip them. That would be during lower firing rates, is where your higher gas pressure is going to be normally. You would have to try to test it there. You could put a manometer in the line, or some kind of a pressure sensing device to see where you're actually at, and then manually trip it, and then go back to where the setting was from the service technician. But if it's too far out of range, you may not have the gas pressure switch that's recommended by the manufacturer. So you got to check that too.
Yeah. Yeah.
So that there's codes as far as what the range of a gas pressure switch is supposed to be in relationship to what the normal gas pressure is at a boiler. So that's got to all be looked at.
So what you're saying in that particular case, that within the question, That might be the wrong high gas
application. It could be the wrong application.
It doesn't have a high enough range or a wide enough range.
Correct. Okay, thanks.
Next
Okay,
question.
I know we've still got a multitude of questions that have come in. So if we don't get to your questions, we will be sure that we do have them recorded. Once you send them in through the application, we're able to keep those, and we'll make sure that we get those answered and get an answer sent back to you. So if we don't get to your question today, don't fret. We'll try to get an answer back to you as soon as possible.
But we're going to post those, right, Susan?
Yeah, we'll post the questions. We'll post the questions, and we'll have them located up under on our website where you find the PowerPoint and the link to watch the presentation in its entirety. Then you'll be able to also see the Q&A questions that were asked and the ones that we answered. So just a couple of more questions, and then we're getting up to the top of the hour, so we'll wrap it up. Is there a rule of thumb to which fuel is tuned first on dual fuel burners?
I think what should be done is the fuel that's going to be the primary fuel should be set up first, and then you would set the secondary fuel up second. So say if you've got number 2 oil and gas and you're in a place where you can burn the diesel fuel, or they're going to burn the diesel fuel first, that you should probably, you might want to set that up first to make sure it's going to work optimum, because that's going to be your primary fuel, and vice versa for natural gas. Okay, next question.
Okay, maximum stack variation refers to what actual value? Can either of you answer that one?
Yeah, he's referring to stack pressure at the exit of a stack. Over the last few years, the requirements for stack draft have changed a lot, the envelope in which a boiler can run. Back in the early 90s, we started doing the low emissions. Before we got into the Cleaver-Brooks low NOx boilers, and others probably too, the envelope for a boiler stack pressure would be plus 0.5 inches to minus a half an inch. Now we're getting down to envelopes of plus or minus a quarter of an inch with the lower NOx boilers we have now, down to 9 parts per million. So that's what that,
Exactly, and that's exactly right. So as we've gotten more involved with flue gas recirculation and things like that, the tolerance has narrowed to a half inch plus or minus, to a quarter inch plus or minus. It used to be a half inch. Now that's Cleaver-Brooks. Now you might have a competitive boiler out there, and that's why it's so important. You've got to check with that manufacturer to find out what their tolerance is. And when we're talking about this tolerance, we're talking about the vent stub coming out of the boiler, okay, before it goes into the stack. There's a vent stub that the stack flange connects to. It's right in that area right there where they're going to say plus or minus a quarter, plus or minus a half. So it's very important you know that. And that is going to vary most probably with manufacturer.
Okay. All right. I have just over the hour, so we'll go ahead and wrap things up. When the attendees, when you leave the WebEx program, you'll be automatically delivered a survey. We would appreciate you filling that out. Give us a little bit of feedback. Tell us what we're doing right. We'd like to think that we're getting better at these things, and the topics are timely and valuable to you. So let us know how we're doing. And we'd also like to poll you for additional topics. We have the calendar set for pretty much the rest of the year, but we can switch things around if we have, we know a topic is more timely and needed. We can certainly try to plug that in. If not, we can certainly get it on the schedule for what's coming up in the future. So again, please feel free to fill out the survey, give us your feedback. If you request a certificate, make sure you've indicated so, and we'll try to get that back to you within 3 to 5 business days. And I want to thank Steve, as always, for the wonderful presentation. And Ron, thank you for adding to our expert panel. And for all the questions that we have, Steve and Ron, we'll get those sent over to you and let you take a look. And then as soon as we get those answered and kind of organized, we'll have them posted up on our website. Again, you can find a copy of this presentation, the PDF document of the PowerPoint, the link to the WebEx so you can hear, if you missed any portion of this and you'd like to hear it all again or what you've missed, you can find that at cleaverbrooks.com/webinars.